Okay, let's go ahead and talk more about the data analysis for today's lab. So I picked some random data here and I did 3 trials. So in trial 1, I halved the amount of iodine. And in trial 3, I added 5 milliliters to the amount of acetone. In both, I'm keeping everything else the same. So I only did 1 trial for each. So I have the average time in seconds it took here. Now, what is my first step to do in the data analysis is to find the concentrations initially used of each reactant. So our stock solutions had these concentrations. Acetone 4 molar, iodine 0.005 molar, and HCl 1 molar. So we need to find out when it's all mixed, what was the initial concentration. For a dilution, we should use the equation M1V1 equals M2V2. You can also do it this method here with the train track, but I find that's a little more complicated. So let's start. Acetone was given to us for trial 1. So we'll start with iodine for trial 1. So M1 should be the stock solution. V1 should be the amount used of said stock solution. For trial 1, that was 10 milliliters if you look at our chart here. We're trying to find M2. And we know all these will be 50 milliliters for V2 because that's how much we're diluting our solutions in total. So once I do that, I should get 0.05 here equals M2 times 50 divided by, I should get 0.001 molars equals M2. So that should be true whenever we use 10 milliliters iodine, which also occurs for trial 3. Trial 3 will also be 0.001. It was already given to us that it'd be 0.8 molars for acetone whenever we use 10 milliliters, so that'll be the same for trial 2. And we just have to do this equation 2 more times. So next, we'll go ahead and do for trial 3 acetone. M1, or stock solution of acetone, was 4 molars. Our volume used for trial 3 is 15 milliliters. Trying to find M2 and B2 is 50 milliliters because that's the total solution. 60 molars times milliliters equals 50 milliliters times 2 by 50 milliliters, both sides. $1.2. molars. Now we just have to solve this equation one more time. For trial 2 iodine. So M1 of iodine again is 0.005 molars. The volume used in trial 2, 5 milliliters. M2 is what we're trying to find. V2, the 15 milliliters. .025. What is that? Just give me 5 times 10 to the negative 4. 1, 2. Very small number there. So now we have the initial concentrations. Okay, next, we can find the rate of each trial. So we are given the average time. So for trial 1, 433, 148. And 191 seconds. Now it's asking us for the change in concentration of iodine. So change in concentration is the iodine final concentration minus iodine initial concentration. Iodine was the orange solution, so it was completely clear at the end, meaning we had none left, so our final concentration is 0. So it'll just be negative of what we have calculated above for molarity of iodine. So trial 1 and 3, negative 0.001. And for trial 2, negative 5 times 10 to the negative 4. And the rate is the negative delta iodine, so it'll become positive again over time. So just take this number divided by this number. And then make it positive. (2.31 times 10 to the negative 6). So there's how I calculate my rates, and I get my rates for each reaction. Now we need to find M and N. So remember, this is from my general rate law. Rate equals K. Acetone M iodine. And so first, let's solve for M, or a reaction with respect to acetone. First, we need to go back to our table and say which one is acetone, which two trials are acetone changing, but everything else being the same. That would be 1 and 3. So I will take rate 1 over rate 3. And plug in the respective values. So I need the concentration of acetone for rate 1. It's 0.8. For 3 is 2. And for 1 and 3 in iodine, it's 0.001 to the end. So then that's divided by. So whatever's the same will cancel out. My k's cancel because they're the same. 0.001 to the end cancels out. So we can more simply look at this like this. And then we'll plug in our rates here. So rate 1, 2.31 times 10 to the 6. Rate 3, 5.24 times 10 to the 6. Now in my calculator, I'll take 2.31 times 10 to the 6 divided by 5.4 times 10 to the negative 6. Negative 0.441 equals, and I'll just take 0.8 divided by 1.2 in the calculator. It's 15.667. And then we're still going to raise it to the m. Now, what we're going to do is we're going to raise each side to the logarithm of 10. So log of 0.441 equals log of 0.667 to the m. And the reason we do that is because of the rules of logarithm, that m will drop down. So this is the same thing as the log of 0.441 equals m times log of 0.667. I'll now divide both sides by log 0.667. M equal 2.02, which we will approximate to its closest whole number of 2. So m is approximately 2. Let's put that there. And now we'll do the same thing to solve for n. So for n, which trial did we change? Just the iodine. That'd be between 1 and 2. So I'll take rate 1 over rate 2. In here, so trial 1 concentration of acetone is 0.8, and it's also 0.8 for trial 2. Iodine trial 1 is 0.001. And trial 2 is 5 times 10 to the negative 4. So things that are the same will cancel that. So we'll simplify this out a little. And then rate 1 is 2.31 times the negative 6. Rate 2 is 3.38 times the negative 6. So then we'll divide out again. 2.31 times the negative 6. 3.38 divided by 3.38 times the negative 6. 0.683. 10.001 divided by 5 times the negative 4. That's 2. And we're still raised to the n. This row will take the log of both. Remember, the same as log of 0.683 log. But I've said log. This gets me an n value of negative 0.55. In this case, we're rounding to the nearest whole number. If you get a number like this, go ahead and round it to 0. If it's between -1 and 0, because it's most likely 0, it's just a little off from being rounded to 0 anyway. So 0 is our nearest non-negative whole number. And then one step further, that is important is to solve for K, because we want to eventually find the specific rate law. So to do that, you can pick any trial and plug everything except for K into your rate law. So we'll do number 3 this time. Our rate of trial 3 was 5.24 times 10 to the -6 molars per second. Trying to find K. The concentration of acid shown for trial 3 is 1.2. And that's raised to the M, which is 2. And our concentration of iodine is 0.001. Raised to the N, which is at 0. And these are both in molars. So adding the 0 power is 1, so that'll just kind of disappear. So K, I'll divide by 1.2 molars squared. 1.2 squared. And so because this is molar squared, the unit on the bottom is molar squared, so only 1 molar cancels out. So there's still, so there'll only be 1 molar on the bottom. So calculating this. This gives me 3.64 times 10 -6. Units are seconds to -1, molars to -1. Because again, I had molars per second divided by molars squared. So this top molar cancels out with 1 of the molars. So it gets me seconds over molars. So that is my answer for K. So that is all you need to know for the data analysis calculations of this lab. If you have any questions, you can visit me in office hours on Tuesday, Sav's office hours on Fridays. Send me an email. Let me know. I will see you all next week.